Complex numbers. In this video, we're going to learn about complex numbers and operation on complex numbers as well. So first of all, what's the definition of an imaginary number? Now in math, we have I squared, which is I is an imaginary number, and I squared equal to -1. Or we can say I equal to square root of -1. So this is my imaginary unit. Therefore, square root of -a, that's I square root of a. So let's gonna see examples with numbers. Square root of -4, that's gonna be 2i. Because square root of 4 is 2, and square root of -1 is I. Square root of -9 is gonna be 3i. Square root of -75, keep in mind, -75 is the same as 75 is the same as 25 times 3, so square root of -75 is the same as 5i square root of 3. So square root of 75, that's the same as square root of 25 times 3, and that's how we got the 5 from square root of 25. Now square root of -8, that's 2i square root of 2. Similarly, square root of 8 is the same as square root of 4 times square root of 2. So square root of 4, that's 2. That's how we got the 2. And square root of -36, that's 6i. Square root of -90, that's square root of 9 times 10 times I, that's 3i square root of 10. So now we can take the square root of a negative number. Now, any number written in the form a plus bi or a minus bi is a complex number. We have the real part and we have the imaginary part. So the real part is the one not attached to I, and the imaginary part, the part that attached to I. So for example, 20 minus 3i, 20 is the real part and 3i is the imaginary part. 2 plus 7i, 2 is the real part and 7i is the imaginary part. 10 plus I, 10 is the real part and I is the imaginary part. And -21 is only the real part and the imaginary part is 0. -7i is the imaginary part and the real part is 0 in this case. And keep in mind, in this example, the imaginary part is -3i. Now, to add and subtract complex numbers, we add the real parts and we add the imaginary parts. Similarly, when it comes to subtraction, so we combine like terms. So we're adding two complex numbers. So first of all, we're going to group the real and imaginary terms. So 11 plus 8, that's 19, and 5i minus 2i, that's 3i, and we're going to write them in a complex form. Another example, so we're going to group the real and imaginary terms, and we're going to write the answer as a complex form. Now we're going to do subtraction, but first of all, keep in mind, when we do subtraction, we have to distribute the negative. So we have to distribute the negative sign. So negative 1 times 7, that's negative 7, and negative 1 times negative I, that's positive 9i. So we need to distribute the negative sign. Then we're gonna group the real and imaginary numbers and write the answer in complex form. Another example, keep in mind we need to distribute the negative. Negative 1 times 6, that's negative 6. And negative 1 times 5i, that's negative 5i. And we're going to group the real numbers and simplify. And we're going to write the answer in complex form. Now the product of two complex numbers. So we have to do the foiling method. We have to do the foiling methods. So A times C, A times DI, BI times C, and BI times DI. And keep in mind I squared equal to negative 1. Keep in mind I squared equal to negative 1. So anytime we have I squared, we need to replace it by negative 1. So for example, 3i times 7i, that's going to give me negative 21. More examples, 5 times 6i, that's 30i. Here we distributed 7i, and keep in mind instead of I squared, we're going to write negative 1. More examples, so we did the foiling method for this example. We combine the middle two terms, and instead of I squared, we're going to write negative 1. And the final answer is going to be 33 plus 4i. Now these complex numbers are called conjugates. Notice only the middle sign is different. So the product of two conjugates is a squared plus b squared. And that's a proof. So for example, we have two conjugates, so the product is going to be 5 squared plus 4, and that's going to be 29. Dividing complex numbers. When you divide a complex number, you need to get rid of I in the denominator. Anytime you want to divide a complex number, you need to get rid of I in the denominator. So here, for example, we can only multiply by I. Distribute, and then simplify. Now here, to get rid of I in the denominator, we have to multiply the denominator by the conjugate of 2 plus I. To get rid of I in the denominator, we have to multiply the denominator by the conjugate of I. Now here we're simplifying the result, and we're writing as a complex number. So square root of negative 81, that's 9i. Square root of negative 64, that's 8i. And we're writing the answer as a complex number. This one, square root of 16 is 4, while square root of negative 50 is 5i square root of 2. More examples.